Okay, next is fancy indexing. Well, I don't know why it's called fancy indexing, but it is indexing through giving a list. So instead of specifying, a range, okay, if you can do a colon means everything. Okay. 2 colon will be starting from 2 everything, or colon 3 will be from the beginning up to that point, right? But what if it is not a contiguous range of rows that or elements that you want to select? You want to pick like the first one, 5th one, and the 6th, 17th one. Okay. So when it is not a contiguous list, which can be represented as 2 colon 5 or colon 2 or whatever, so those are continuous ranges. Okay, if it is discontinuous ranges, then you can do it this way. So that's what is called, and it need not be in the same order. So you can mix the order, like okay, 0, 2, or it can be 2 and then 0 and then 1 and things like that. So here we run the example data. Okay, then select elements with fancy indexing. So this will you give that as a list. Okay, so this is your indexing square brackets. Now, inside the indexing square brackets, you give a list of elements that you want to select. So if you have only one list, then that's going to come from the first dimension. So from the first dimension, you want the 0th element at index 0 and element at index 2. So element 0 starting 1.62 and element at index 2 will be 1.46 and so on. So those 2 rows get selected. Okay. And you can change the order of the elements with fancy indexing. So you go 2 first and then 0 and then 1. Okay, so that will work. Okay. Now fancy indexing in 2 dimensions. Okay, right now all we did was from the first dimension. What if you want to select numbers from both, you want to specify coordinates from both the first and the second dimension. Okay, so if so you give it as 2 lists, right? So you give one list for the first dimension and another list for the second dimension. Okay. Now, so there is a problem here. Okay. Again, like in the broadcasting. Okay. So if one of the shapes of the fancy index is 1. So, well, before that, if shapes of the 2 dimensions do not match. So you give the first dimension you want 1 and 3, the second dimension you want 0. Okay. So you don't have the same number of elements. You're not selecting the same number of elements from the two dimensions. Then each of the, if there is only 1 in one of the 2 places, then each number here will be paired with the other. So you'll have 1, 0 and 3, 0. So this will be same as you want 1, 0. So it will be like 1, 0 is what? So this is the, so 1, 0 is that. So 0, 1 and then 0 would be that. So that will be 1, 0 and then 3, 0 will be 0, 1, 2, 3, 0, that. Okay. So if there is only one element in one of the 2 dimensions, then that gets paired with everything else on the other dimension. Okay. Otherwise, okay, if the 2 dimensions, if the number of elements in the 2 dimensions are exactly same, then they are paired. So here we are giving 2 lists. We have 2 numbers from the first list, 2 numbers from the second list. So now you're going to pair this. Okay, 1 is paired with 0, 2 is paired with 2. So you will have 1 0 will be that, and then 2 2 will be 2 0 1 0 1 2 0 1 2. So 2 2 will be that. Okay, so they are paired. 1 0 is one coordinate, 2 2 is the second coordinate. If the shapes of the two dimensions do not match, okay, an error is thrown. So like for example, here we have selected 3 items from the first dimension, and we are selecting 2 from the second dimension, then that's not, you can't pair them. If there was only one, if it was just 2 and there was no 3, then you'll get 1 2 2 2 3 2. The single number will get matched with everything. If this one has 2 3 1, then corresponding pairs will be used. But then here the shapes are not same, so you can't do either of them, and therefore you're going to get an error. So you get a shape mismatch error. And you can also do fancy indexing with negative indices. So here it will be -3, so you will start from here, okay, so 0 1 2 3 4, so -3 will be, so this will be -1 -2 -3, okay, so that one. And well, I'm sorry, so this way, so this is start from the end, -1 -1 -2 -3, so that's -3. Okay, and -2 will be that one, and -4 will be that one. Okay. And you can transpose, if you do dot uppercase T, the whole thing gets transposed. All right, so let's look at ARR D3. Okay, I'm going to do ARR D3. ARR 2D3, sorry. ARR 2D3, okay. So what am I supposed to do here? ARR 2D3, extract the first, third, and the fourth element from the first dimension. So from the first dimension, we want the first, third, and the fourth, right? So that will be what? ARR 2D3. Okay. So now I have to now give the index positions, and we want 3 elements from the first dimension. So, and we want to use fancy indexing, which means you have to give the indexes in a list, right? So what should be the list? So it should be, you have another set of square brackets. So the first element will be index 0, right? And then two and 3, right? 0, 2, and 3. So that will give us what we need for 13. Now for 14, we are using the same array, and we want to extract, okay, these are the coordinates, 1 comma 1 element, 0 2 and 3 4, and how are we going to do that in fancy indexing. So ARR2 D3. Okay, so how are we going to do that? Okay. So we have 3 coordinates for the first dimension and 3 coordinates for the second dimension. Okay. So the first dimension coordinates are 1, 0, and 3. So the first dimension coordinates will go in one list, and the second dimension coordinates, which are 1, 2, and 4, will go to the second list. Okay. So when you have 2 lists that have the same shape, then the corresponding elements will be paired. So 1, 1, 0, 2, and 3, 4. Okay.